Hey, what's up, Ziguanas? This is day 20 of the 30 days of Zig Coding Challenge. Join me one more time as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new programming language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. So, day 20 already. Time flies when you're having time, really. So, I will do this stream now, and then in about few hours, let's say, I will do the recap version. So I will do the tic-tac-toe for the third and last time. I will finalize that code. And then next time I will do live coding practice. It will be something different. I will still see what I will do next. But for today, the plan is to play one more time with tic-tac-toe. And in this part is we continue with the documentation, so generic data structures. And then if we have time, case study print Zig. That's next on the menu. So let's jump right into it. Generic data structures, what they say about it. By the way, I'm probably boring to the ones that already watched a few of my videos, but I have to say it for the ones that are maybe here for the first time. So the idea of this series, 30 days of Zig Coding Challenge, is to document my progress of learning Zig. So I had literally zero Zig experience 20 days ago, and I was doing everything in front of the cameras in live stream. So I didn't do anything outside of this stream, so you can completely see my progress. And the point is that I can demonstrate how someone who has experience with dozens of different programming languages, and as a teacher as well, teaching others to code, and as a mentor, how I would approach learning a new language. And it's a bit different than what I would really actually do if it wasn't for stream, because normally I would repeat some things that I already did as soon as I do them, and then this is a little bit boring to do on stream. So that's why I'm just like basically handicapping myself, because I cannot learn that thoroughly as I would like to in this, let's say, 20 days. So if I were doing things normally outside of the stream, I would actually spend more and more time rereading the same things that I already did in live stream. So that's, I think, a little bit boring for the stream. So that's why I don't do it. It's long anyways, long stream even without this. So this is the only difference. Like, what would I do in real life outside of stream if this wasn't meant to be only done during the streaming? But I kind of want to limit myself only to practice Zig, at least in these first 30 days, to limit myself learning Zig only in front of the cameras in live stream, so that's that you can have a realistical image and to see how actually things are progressing. So that's the idea. And after I finish this 30 days coding challenge, I will do more things offline, off cameras, and then I will prepare a tutorial and I will apply what I learned about Zig, and I will, behind the cameras, do a deeper research on topics before I put them in tutorial. So I will kind of like compress the videos and add things to them, but they will be more concrete. So for example, the topic that I use in live stream, like 1 hour, let's say, for a specific topic, I will probably make a 10-minute video about it with only the essence of that topic. That's the idea. Okay, that being said, let's continue with learning Zig. Generic data structure. Zig uses comp time capabilities to implement generic data structures without introducing any special case syntax. Okay, here is an example of generic list data structure. So this is very similar. Sorry, I'm about to sneeze. This is very similar to what I did yesterday, because yesterday I had these, let's say, generic types that are not data structures. So they were just like the basic types. Sorry, I'm about to sneeze, so trying not to. So this is just like the continuation of the things that I did yesterday. So we are now doing the same, but for more complex situation. Here's an example of generic list data structure. Okay, what they say here, and let me zoom in a bit. Oh, now it jumped because I zoomed. Give me just a second to find. Okay, here. So they have this function list, which has the comp time t type, and it returns the same type. And then what they do, they're actually returning a struct. And in this struct, they have two fields. One is the slice of type t, and the other one is the length. Okay. Then what they do here, they create a variable. They call it buffer. Let's first read the comment. The generic list data structure can be instantiated by passing in a type. Okay, so they are first creating a variable called buffer, which is an array of i32s with 10 elements, and they set it at the beginning as undefined. Then they create another variable. They call it a list with lowercase l. And now they're actually invoking this function list, and they pass in the type. So this generic here will become of this specific type. So basically to generate the function that will have the parameter of i32 type, and it will return the i32 type, right? And then they set, they call this function list, and they pass. Okay, they instantiate. So yeah, this is kind of like a constructor. So they will initialize these fields, the items field, with the address of buffer. So they will take this array here and pass a reference to it. And then they will set the length to 0. Okay. So yeah, this is basically like a constructor. They are generating this list. Let's see what they say next. That's it. It's a function that returns an anonymous struct. Let me see what they miss. Yeah, here they are returning the anonymous struct. Okay. For the purposes of error messages and debugging, Zig infers the name, list i32, from the function name and parameters invoked when creating the anonymous struct. Okay. So I'm just a bit confused because they're returning the struct. That's okay. But because this type and this type should match, so here it's i32, not a struct. That's why I'm confused, because they are returning the, so I would expect that this is just returning the i32 if we send the i32 here as a type. And what is the, so here this part, before I saw this code, everything was fine. So I would expect, okay, if you pass the struct as the parameter here, you return the same type, so you can then return the struct here. But this is like the part that confused me, so I'm probably missing something. Let's see if they have something else to explain. Okay, this is what I already read. To explicitly give a type a name, we assign it to a constant. So let's see what they do next. They say const node equals, so this is just to name a type. Okay, because otherwise it's anonymous. So it's a struct which has the next and the name fields. The name is a constant slice of U8s, and the next is an optional pointer to a node, if I'm not mistaken. Then, hi Robert, how are you? Hope you're doing well. So here we have a variable node A, which then they set to the node. So they use this struct here. They set up the next to null and the name to node A, and similarly they do the similar thing to B. For a B node, it's on the same type. So this is different. So the name is node B. So like here it was A, But in this case, for the node B, they actually specify the address of node A, which is the next. So basically, they created a linked list here, right? So this one is now, it's a weird thing. What they did is usually you create a head and then you append to a linked list. In this case, if this is, let's say, the head, if you create the first linked list node, then if you say this one has the next node, this one, then you're kind of like inserting in front. That's why I say it's weird. I mean, of course, you can insert as well, but it's just like not usually the first thing someone does with linked lists. Let me see what Robert is writing. I'm doing great having you up in background when programming as usual. Yeah. Nice to hear you're doing great. Where are you from, by the way? I believe you're from Croatia, right? According to the name. In this example, the node struct refers to itself. Here, they mean here. Node referring to itself. Node struct refers to itself. This works because all top-level declarations are order independent. Okay. As long as the compiler can determine the size of the struct, it's free to refer to itself. So let me just read it one more time. As long as the compiler, because I thought it's not only in this case, I thought it's a bit more liberal, let's say, approach, but it's not. So as long as the compiler can determine the size of the struct, it is free to refer itself. So it's important that it can determine the size of the struct. Okay. In this case, node refers to itself as a pointer, which has a well-defined size at compile. Okay. It works fine. Czech Republic, the beer country. Nice. I've been once to Praha, the capital, and Karlovy Vary also. It's a beautiful country. And I did try some beers. I don't remember, it was a long time ago, but I did try some Czech beers. And I loved Prague, like it's one of my favorite cities that I ever visited. Okay, case study. Oh, you're already at case study. This wasn't so big topic, but I think case study is okay. Yeah. While you're here, Robert, can you just like explain one thing? I misunderstood this one part here, if you can. So here in this example, okay, we have the function list, which receives comp time t of type t and returns type t. And then I see it returns struct here, which is okay. So if you pass here the struct, then you can return struct, it's okay. But here I got confused because they are basically invoking this function with i32. So not a struct, but i32. So integer 32, a simple type. So then I would expect this to be of the same time here, as type here, like here. So i32 as input as return as well. Then I don't know, first of all, how this doesn't break the code and what happens here. Let me see what you wrote. By the way, this order independence of top level declaration is something you already encountered. When you attempted to make struct in the main that referred to itself by, yeah, I remember that. Yeah. So it didn't work in the main, so it had to be global, at least outside of this function. The code you have there. See, takes a parameter type and returns a structure. structure, union, and enum is just another type. Okay, okay. Hello, hello, Mauricio. How are you? Mauricio Rojas. Where are you from, Mauricio? Let me then move on to the case study. Okay, case study print in Zig. Putting all of this together, let's see how print works in Zig. Yeah, it's so like, this is not the only programming language where you actually think something as simple as a print function or hello world code, then you think it's like, on the surface, it seems to be like a very, very simple thing. But then you dig deeper and you actually see that there is a lot of things happening under the hood. So not all of languages, but I've encountered a few of them that are like this. So it looks simple because it's abstracted from you. But then when you go under the hood, you see the things are actually very, very complex. What happens with something that looks simple. So let's see. They constant number. So this is what they do first. They create a constant, call it a number of type i32, 1, 2, 3, 4. Then another constant, a string, foo_bar. Then what they do, call a print function. Here is a string, so this is hard-coded. Then they have this interpolation here. I mean, I call it interpolation because in other languages it's called interpolation. I don't know if they officially call it in a different way here. So string interpolation. And another one here. And we already know this is like anonymous structure, basically a tuple, which has, in this case, these two elements. And then the first one comes here. So a string is injected here, and there is this format, S, so that it can be displayed properly, and then a number. And I guess this is a must for string, if I remember correctly. It breaks the code if you don't specify the S, because string under hood is array of bytes, so they don't know what you want to do by default. Do you want to display like the string representation of it or something else? And the number is straightforward, right? It's a primitive type. Yeah, and the strings are very weird, like in basically no programming languages, if you dig deeper. So they kind of look simple, but they are one of the craziest things in any programming language. Not only like here, there is no type that is a string, but even in Python, for example, where you have a string type, what happens actually under the hood is weird. I mean, not weird. Like, of course, when you dig deeper, then you understand why the things are like that. But at first, when you start digging, it looks very weird. Let me see what you wrote. So what it does, it creates a structure that has a slice. So this is back to this example. Okay. So what it does, it creates a structure that has a slice of provided type and length. Yes, that's what it's here. Also, it caches the type returned. So when you call it again, it returns the same type. Also, most languages have printing implemented in compiler. Zig has it in standard library because you can do it just using Zig. Yeah, that's cool. String yes is necessary. You can ask for array by any or other ways to display it, similar to floats cars. Yeah, makes sense. Thank you. So let's see what else they do. Let's crack open the implementation of this and see how it works. Yes, let's do that. So EOC print function Zig calls print and then flushes the buffer. So let's see how long is it, just to see. Okay. So let's try to go through this. So first of all, it's a constant writer, which is a struct. And I believe until the end, until here, that's that struct. And then let's actually go through this first, through these three functions because they're smaller. Let's just quickly take a look at least. So the first one, write, receives self as parameter, which is a pointer to the writer, that struct right above. Then it receives a value, which is a constant slice of U8s. And then it returns a void union. And here it dumps the self and the value, both of them. This is interesting. Then public function. So this is not public, this is public. And it's the only one that is public in this example. So public function print value, self again, which is again pointer to the writer. Value is any type this time, so not only constant array of U8s, but any type. The same output and the same dump here, self and value both get dumped. And then it has the flush function, which doesn't receive anything else but the reference to self, which is a pointer, and the same output, and it just dumps the self because it doesn't have any other input, so it doesn't need to dump anything. So write print value flush, and let's see what they do here. Let me see what you wrote. They just show that those functions exist but don't show implementation since it's not important for now. Aha, so this is basically the kind of like the function signature. Signatures. Okay, yeah. Got it. Because the implementation is not, in this case, important. They want us to focus on this part, okay? So let's see what this one does. So this is the first function in the writer struct. And are there others? No, there is this com_time block with if statements. There is one more if outside of it. And there is this try, which tries to call this method flush on itself. Okay. Let's then start from the beginning. So first thing they do, they define a constant enum. They call it state. And it takes these three, it has these three, how do you say, not fields, maybe they call them fields officially. So these three possible values. So start, open, brace, close brace, and they call it state. Then brace, they probably mean by the braces, okay? Com_time var, which is start index. They call it start index. By default, they set it to 0 and it's usize as the type. Another one, state, which is the state start. So they put the initial state to start from this enum. Then they have a com_time var next arg. So they have start index, state, and next arg. And next arg is also set to 0 and it's usize like the first one. Then they have inline for. And this is, I believe, running until here, so it's a bit harder to trace here. Inline for, no, up to here, okay. Then they have the format, which is, I didn't go through this function signature. So it's a public function or print, that's what we're analyzing. So it has self-writer, so the pointer to writer, com_time format, and the format is of type slice of const slice of U8s, and they have args that can be any type, and they return the union of any error and void. Okay, so basically if there is no error, there will be no return. Okay. So then back to here to the for. So they take this format that is known at com_time, right? So this format here is passed during the compilation time. Then they take, I believe this is to generate the indices, so that they can kind of like make the that they can use all the things from the slice with the index in the same time they generate. So they say C, I believe a character, right? That they want to say it's a character, and I, the index of it. So this is the capture group. And then inside they have this switch. I know the switches are very interesting in Zig because of the state machine. Let's see what they do. So they switch the state, which is this enum, and it starts like this one. So they have the case if it's the start, if it's open brace, and if it's closed brace, right? And yeah, they covered all the branches, of course. And let me see what you wrote. Just saying this is deprecated simplified implementation. Current one is way more complex. Has a lot more compile error messages when something is not right and other goodness. So it's nice to okay. So you mean like this code that is inside of the writer, or the signature of these functions? These three functions are, or maybe all of them. And let's see here how they go through these three potential states. So if it's a start, so they switch again, right? So for every state, they have additional nested switch. So no matter which of these three states, they will switch also the character inside. Basically, oh, thank you. Well, okay, I will go through it anyways just to see like how this version worked. So then it will probably be easier also to understand the new one when it comes. If I and it will be interesting to see the improvements. So here, when the start state, so when the enum is in this state, in start, we switch the character, and it has two branches and the else. So if it doesn't match anything, it will have the value. So this switch will produce or return, however you want to say, empty struct, right? Or no, this is the void. How I forgot what is this is the void, basically. I didn't mean you should not go through. We're just saying it is not the current one. Yeah, thank you. It's nice to know. So let's see if it's open curly brace and so they basically have it's cool. So this is how they analyze. Okay, nice. So they take character by character. So if it's the open and curly brace, then they have this question. If start index lesser than I, they try to self-write. So they call that function or method above, below. And then they call another one format, right? They are all to write, print value, and flush are here, okay? So then this format is actually, yeah, this is coming from here. It's not a function. I forgot already. So they are trying to call self-write, and then they pass the format slice from the start index to I, okay? They try that, and then they try to, not try, but they set the state to open brace. So they confirm that this is now open brace, okay? If it's the closing one, if start index is lesser than I, they try basically the same thing from start index to I, and then they change the state to close brace. Else curly brace, so void, okay? So state open brace, switch C again. And in this case, they have not only, so if the brace is already open, right? So then it can potentially have also this part here. So curly brace. In this case, if it matches the curly brace, they set the state to start. and here they set it to open and close. So they then reset to the start. So this is by default. Whenever they start, they put it to start. Okay, and start index equals I. So they're resetting basically so that it can include everything needed. So yeah, because here they're right. Yeah, so they kind of like do it in steps. So they finish one part and then they reset everything so that they can work on the next thing. Let me just see what you wrote. And I would not recommend to go through the current one since it's going to change soon. Yeah, so I'll just quickly go through it just because I started, and then we'll move on to the next thing. So basically, I see if they are encountering now the curly brace or the closing one, they are. So here, if it's closing, then of course it's the end of it. So then they try to print value with the args next arg. Okay, then they, and because of this changing the state, it can actually rerun the switch. Yeah, I have to keep that in mind. The switch in Zig, it doesn't pass through, it just goes back with continue. I mean, okay, so state start. Okay, start index I plus equals 1. So if it's string, if it's S, then they continue. Else compile error. So this is the, if it doesn't match any of these three, unknown format character. Okay, this is what I've seen a lot of times when I didn't use the S, then this is what was showing, unknown format character. Then the last part, state close brace switch C. Okay, if it's curly brace that is closed, they again reset the state to start, the index to 1. Else, so this is literally like everything that they support. Anything else is compile error, single curly brace encountered in the format string. Okay, com time. If args len not equal next string, unused arguments. I've seen also this. If I had, let's say, 2 pairs of curly brace and I had 3 things in this tuple, I've seen this error, I remember it. If state not equal state start, incomplete format string, ++ format. Okay, so I think this is when you don't have curly braces, if I remember correct, yeah. If start index lesser than format length, try self-write format start index until the format length. So in this range, but only if start index is lesser than format length. Okay, makes sense. Try self-flush. Okay, let me see what you wrote. Current std fmt format type is cool to look. You can see the common compile errors you get when you make a printing mistake. Let me see what a realist wrote. Watching some Zig while my Java monolith is building. Yeah, always use the time. Yeah. Yeah, I used to work with Java a lot. I worked on some crazy projects, so I was like, last time I worked with Java, I was one of 200 developers on a project. So the company had more, but this project had 200 Java developers. I didn't even know who they are. So I just like knew maybe 5 guys from my team. And it is so huge project. So if you just like go to the user interface and then you have like 20 tabs, and then if you click on one tab, you have like a form that is huge. It has like, I don't know, 50 different fields. And then when you click one of them, it opens up, it's nested, and then you go to the next stage. So it's very, very complicated. And it was some custom framework, nothing like Spring or that is used commonly, but a custom components framework, and it was, I think, Java 7, so a lot of legacy code. Back in days, the Java, I think, what was the latest version for sure? It was 5 years ago, so Java had at least 5 or 6 versions after 7, even more. Now it's what, 21 is the latest one. Okay, this proof of concept implementation, the actual function in the standard library has more formatting capabilities. Note that this is not hard-coded into Z compiler. This is userland code in the standard library. When this function is analyzed from our example code above, Zig partially evaluates the function and emits a function that actually looks like this. Yeah, because of this comp time and inline things, so it will. So they say emits, so I'm trying to use the right terms. Emits a function that actually looks like this. I was going to say something like it's going to construct a function or something like that, but yeah, maybe this is the best term. And let's see how it looks like. So arg0, okay, this is now concrete and it's different here. Try, because there are no errors, right? So they try 6 times to write print value, write flush in that order. So this is the result of switches, and this is how it came out. Here is a string, then they print the arg0. Here is a number. So this is, where is the code actually they call? I just want to see the call where it was. Here. Yeah, so here is a string, then the first parameter with s, and here is a number, then the one without, and then we have a string and a number args, right? So that's why 0 is the first one, arg1 is the one, and then after they had this as well in the hard-coded part, and that's the end of the string on the left. I mean, the only one in that print, and then they self-flush. Okay. I remember flushing a lot in C. Yeah. Let me see what you wrote. Sounds horrible. I've seen those projects too. Yeah. So this is when you work in a huge company. So never once in my life as a developer, as a Java developer, I worked on something that is like the latest technology. Never once. I did though in one startup when I was working afterwards with Python. I did, like, I had a choice what to use, and actually I had a choice, but also the project was started in Django, and Vue.js was on the front end, so it was kind of like nice for a change to work in something that is used by others. If you have some problem, you can Google it up and find. In this case, what I did, so you don't have any answers on the internet. Okay, so let's see. Print value is a function that takes a parameter of any type and does different things depending on the type. Print value. Okay, so now they're showing this one, and they are using it here and here, right? So when they print args, they're using that one. It's nice to see how it's organized, at least in this version. So in this case, writer is a struct, and it has one public function inside, and it has again this helper function that it uses. So again, we see I guess we see just the signatures, not the actual implementation. Then it has the switch. So first of all, it receives writer and value of any type, void union as a return, then switch, and it switches the type of the value. So it gets the type of, and then gets the type info of that, and then it sees if it's .int, then it calls, it returns the call to whatever this write-in function returns, right? So it's kind of like delegating. It passes the value to a call to the right integer, and whatever this returns, it will return. and similar for float and pointer. It calls the appropriate methods or functions, how I want to call them, and does the same. And then only in else there is a compile error. So basically it accepts integers, floats, and pointers, nothing else. Nice to know. Integers, floats, and pointers. Yeah, so numbers and pointers basically. Okay. Of course, there is but there is also coercion. So they will coerce something as well so that it fits into these three types, but this is, let's say, the general idea. Else, compile error, okay, unable to print type, and then they take the same, so not the type info, but they take the name of the type so that you at least have the information what is the type that is not supported. Okay, nice. Let me see what you wrote, guys. Unless that big thing was clean in terms of architecture and code. Well, it was very hard to work with. So I will say, because I will not mention the name of the company, so I can say a bit about the structure. So I don't want to like speak bad about the company, but let's say I had a ticket, for example, once, and I spent I don't know how many hours trying to figure out how to solve it, and then I figure out, because it's like inheritance, like it's I don't know how many generations of abstraction and everything, and it was very hard to trace. And then eventually I went through all these things, and I figured out that what they want to do cannot be done unless I touch some of the parent classes, which of course they don't want you to do. And first reaction of one of the guys who was actually the initial designer architect of this entire system, he told me like, no, that's impossible. Like you just like couldn't find a way. And then he tried to do the same thing. And then he said like after, I don't know, one day, yeah, you were right. So this is impossible to do. So they just like said this ticket, I don't know what they officially returned to a customer, because it was like a customization thing, but it wasn't, it was rejected. Hello, Idris. How are you? Let's see what Robert wrote. The beauty of this is that all the logic happens at comp time. Yeah. At runtime, you have only the correct write functions in order based on the format you provided. Yeah, that's cool. So you are basically stopped at comp time. Any like silly business you want to try, it will be prevented, and then the code that you actually run, the binary is optimized and clean. Okay, let's see what they say. And now what happens if we have too many arguments to print? Okay, constant number and a string again, like before. Iterate to 1, 2, 3, 4 and a string literal. Then they have two curly braces here, and they try to pass a number 2 times. And yeah, this is the unused argument, so this is back here from where it was here. Yeah, I remember this experiencing on my skin. Okay, Zig gives programmers the tools needed to protect themselves against their own mistakes. Zig doesn't care whether the format argument is a string literal, only that it's a compile time known value that can be coerced into a slice of U8s. Yeah, so this is what I mentioned, that not only these three types, but also anything that can be coerced into those types that are supported for this. Like I was just speaking about this part when they call the print value, not the entire thing. Okay. Then let's see what they do here. The same, two variables, actually constant, not variables. Then, this time they assign it to FMT. Here they just called it. In this case, they are, they are using the expression not to send it to the print function, not to print it, but just to actually do the same job under the hood, but to store the result in the constant, not to directly use it in a print. And then they say here is a string s, here's a number, so in this time it's correct, right? They have, I mean, we still don't know. No, so this is just like, okay. So they are basically, this is just like a string. At this level, it's just a string. Literal doesn't have to do anything with this. Yeah, this was, yeah, sorry, my mistake. So this is, of course, just a string literal. And here they are using that literal in this way. So they just use the variable, not the variable, the constant instead of the literal. But then they inject these parameters and then they trigger the print from the above. Okay. Yeah, for a second I forgot that this was actually the part of print, like this parsing process. It was not another function that print calls under hood, but it was actually the print that did this, parsing this. Let me see what you guys wrote. Yeah, that's why composition over inheritance is so important. Yeah. I mean, I guess they had good intentions. They started like, we need maybe 20 classes, and then that grew to 50, 100, 200. And I mean, down the line, down the inheritance line. Robert, what you say, I worked at a C++ company that wrote high performance servers. That's interesting. We had to rewrite out of inheritance. Because it was so slow. Yeah. Yeah, so generally when we was learning when we were learning programming at my university, what they told us is basically like the old school programming from, I don't know, 70s, 80s, I guess. So they said that generally you had like two schools of programming, like the Western school, and they call this system the Russian school. So they said like the Russians were making things very specific, like custom made code that runs extremely fast, and they didn't do these modular things, so no abstractions and things like that. And it was not related to any specific programming language. They just like told in general. And like the Western school was like to have these abstractions and everything so that you can modularize the code so that you can resell it. So when you have a different client, so they were like more oriented towards the clients and towards, let's say, the economical part of it, so that they can quickly serve, I don't know, 5, 10 clients and take 10 times the money. But of course, then they had to sacrifice the performance because they made it in such a way that they can just like use the pieces of puzzles that are maybe not perfectly matching the current project, but they simply had already like the ready-made code that they can reuse. And this, like the Eastern Russian school, they were using they were like customizing and like counting every assembly step if they can optimize so that they have the same effect, but to have the larger speed. So this was like back in time, of course, not like 2025, it's different, but back in days when you actually had much smaller machines, like in terms of memory and processing power. But even then, this was happening. So I guess this is also true today, maybe in a different way a bit, but let's say using framework for something and doing a completely custom code for something. So of course, rarely in some commercial companies, they will use something and write a code for one thing that is not a framework thing. Let me see what you say more, like 2, 3 orders of magnitude. Yeah, that's incredible performance change. So not 2, 3 times, but the orders of magnitude. Yeah, that's huge. I'm all for code reuse, but inheritance is bad way of doing, so it costs a lot of performance. Yeah, I agree. One of reasons I like the Zig project, you can abstract at 0 cost most of the time. while it being convenient. Yeah, that's important, so that you can not only abstract, but the convenience part is also interesting, because it's different if you have to spend like hours trying to figure out your own code and how it works, and if it cannot be done in an easy way and how you say convenient way. Okay, let's see what they say next here. Oh, we reached the assembly, so this is basically everything that I plan to do for today. Just let's see if I missed something. No, I think this is it. This works fine. Zig does not special case string formatting in the compiler, and instead exposes enough power to accomplish the task, this task in userland. This is nice how they call it userland. It does, so it's the second time they use the word. It does so without introducing another language on top of Zig. Yeah, that's also very cool. Such as a macro language or a preprocessor language. Yeah, like in other languages. It's Zig all the way down. Here also inline while inline for. Yeah, so this is kind of perfect that during day 20 I reached the assembly, which is kind of like a completely different chapter. So it's kind of nice that the first 20 days we made it to this part. Like we can run it up like before assembly and after assembly. Okay, so I will then pause, actually stop this stream here. I will not touch assembly today, so I will do that tomorrow. And what I will do, like I said before, I'm going to, after this stream, I will have just like a small break, maybe hour and a half or so. And I will then stream one more time. For the third time, I will do tic-tac-toe. So I will reuse the code that I had before, and I will just like play and add elements that I've learned in between. So I think I did like 4 or 5 days ago, the last version of tic-tac-toe, and I went through some interesting things afterwards. So I will try to implement as much as possible those things in this tic-tac-toe, and that's the last time I will do tic-tac-toe. So today I'm going to wrap it up, and then the next project will be something different. I still don't know what it will be, but something different. So only if I had something, for example, like previous attempt to finish the tic-tac-toe, the second version of it, I had these bugs at the end, so I did fix them. So offline, I just used AI, so I will show the prompt and everything and the answer of AI later today. And only if something like this happens, so if I don't make it today to like wrap something, wrap this tic-tac-toe game so that it's, let's say, the code that runs without any bugs, then I might do one quick update video, not the stream, but just like the update, just to say, okay, I fixed the bug in this way and so on. So this is the idea, that I will not touch this tic-tac-toe anymore. I will move on to something new in, let's say, 5 days, I believe, not sooner. So after day 25, maybe even sooner, I will see. I don't have idea how many things are left here. I mean, I kind of remember that there are just like a few chapters left, but I don't know how long they are. So that's the idea. Let me see what you guys wrote. Robert, I don't think you need to go over the assembly. It won't give you much for now in your opinion. Okay. By the way, can I get a contact for you? Yes. So you can Google me up, my name. So I think on here on YouTube, you cannot write any message there, no DMs or something. So if you Google me up, you will find me for sure. Like I'm all around the internet. And you can also, yeah, I think this is the best. So whatever. So because I'm, you will see, you will find me in several social networks and other things. So whatever works the best for you. And obviously, maybe I will also write something like my contacts in the bio here, like the section of the bio, so that it's available for sure if you need help with something or had questions. Yeah, that would be perfect. Thank you. Thank you. So this would be it for day 20. And like I said, I will see you guys in about 1 hour and a half approximately with tic-tac-toe. Thanks a lot. Thank you, Robert. As always, you were a lot of help, and see you soon. Bye bye.